Okay, so exponential distribution is now a continuous distribution, and this is very much related to the Poisson. Okay, so it says suppose that some event occurs as a Poisson process. Okay, so similar to what we were talking about last time, the Poisson process is counting the number of occurrences something happens in a time interval. So this is going to be a little bit different with exponential. Okay, so that is the number of time an event occurs in a Poisson random variable. For this, let x be the random variable of the interval between successive occurrences of the event. So rather than us counting the number in a 10-minute period of drivers that come through a McDonald's drive-through, the exponential variable is saying that what is the time that occurs between successive people that come through the drive-through. So really we're just talking about one occurrence to one other occurrence, and then the time between those two. Okay, so the time is then now our variable. That's going to be our x variable, essentially. And time is measured in an interval, and that's why it's continuous, okay? So yeah, it goes on to say that the interval can be some unit of time or space, and that way we know that it is described as an exponential distribution with parameter lambda, which is the mean number of events that occur per given the interval. Okay. And right here we have f of x. F of x is equal to lambda e to the negative lambda x. And the way that we find a probability is this formula right here. So it's a probability of an interval. And we go on, we have that formula expressed again right here. So here is, let's draw. So this was our p of x or our f of x, however you want to look at it, for the continuous random variable that's exponential distribution. This is the way that we would find an interval for probability. This is the way that we would find an interval that isn't between two numbers. So this would just be the bottom end of the function, and this would be the top end of the function. So x is greater than some number, x is less than some number. And now again, in the continuous, the less than or equal to or greater than or equal to is not important. That's only important in discrete. Okay? And then here's how we find our mu of x. It's just going to be 1 over lambda, and then sigma x is 1 over lambda as well. So very easy formulas for mean and standard deviation. Okay, I believe that is our last slide for this. It is. So let's look at the exponential distribution and go to number 7 on your worksheets. Suppose that the random variable x has an exponential distribution with lambda equal 3. Okay, so this is page 248. Number 649, write the formula for the exponential distribution, exponential probability curve of x. What are the possible values of x? Okay, so I'm just going to do A right here so I don't run out of room like I did last time. And using the formula, we get f of x is equal to lambda, just 3, e to the negative lambda x, and this is for all x greater than or equal to 0. And then we say it's worthless otherwise. So 0 otherwise. And that's just going to account for negative x values, because we can't have like negative space or negative time or anything like that. Okay. Sketch the probability curve. Sure, fine, we'll do that this time. Okay, so that's supposed to be a straight line with at 0 with height of lambda, so 3. It's just going to be kind of a smooth-ish curve going down like that. There are better examples of this in the book, so feel free to open up the ebook or look at the slides. I think I had some graphs in the slides. But yeah, so obviously if you need to present it on a test, it should look better than that. But that's about all I got with writing with the pen here. Okay. So as always, it wants us to find probability, and I'm going to go ahead and show you how to do that probability using the formula, using Excel, using Megastat, and actually there are no exponential tables in the back of the book, so we'll just be using those three methods. Okay, so just the formula, Excel, and then Megastat. Okay, so C is asking us, what is the probability that x is less than 1? Okay, so we would go back to our sheet, and we would see that the probability that x is less than or equal to anything is going to be 1 minus e to the negative lambda and that number, c. Okay, so this is going to be 1 minus e to the negative 3, because that's our lambda, times that number, so 1. Which then is equal to 1 minus e to the negative 3. And then if we calculated that all out, that's 1 minus 0.04978, which is equal to 0.950, roughly. Okay? So in D, we're going to go ahead and calculate D just as we would. So D is probability that x is between 0.25 and 1. So we go back to the PowerPoint and we find the formula for this. That's right here. And that is just going to be e to the negative lambda a, so the bottom of the range here, minus e to the negative lambda b, so the top of the range here. Okay? So we say e to the negative 3a, which is 0.25, minus e to the negative 3, because that's lambda, of 1. Okay, so this is going to be e to the negative 0.75 minus e to the negative 3, which using our calculators we can figure that out, and we get 0.4723 minus 0.04978, which we actually knew that from the last problem, and we get roughly 0.423. Okay. I guess we'll go ahead and just calculate, we'll just hand calc all of these, and then we'll go do some of them in Excel. And now it's asking us the probability that x is greater than or equal to 2. So we go back here, we look, greater than or equal to is just going to be e to the negative lambda c. So e to the negative 3 times 2. So e to the negative 6. And e to the negative 6 is 0.002. Okay? And then so F says calculate the mean, variance, standard deviation. So our mu of x, we just go back to the table. So mu of x is going to be equal to 1 over lambda. So we know that it's equal to 1 over lambda, which lambda is 3. So it's going to be 1/3. That was easy, right? And then we also have a formula for sigma x for our standard deviation, and that is also going to be 1 over lambda, so 1/3. And then we know that variance is just standard deviation squared. So then that's just going to be equal to 1/3 squared, or 1/9. Okay, part G. Find the probability that x will be in the interval mu of x plus or minus 2 sigma x. Okay, so we just calculated what mu of x is. So mu of x is equal to 1/3, and sigma x is equal to 1/3 as well. So let's just calculate what this interval would be. So the interval of mu of x plus or minus 2 sigma x on the bottom end. So we'll just say 1/3 minus 2 times 1/3. And then on the top end is going to be 1/3 plus 2 times 1/3. Okay, and that's going to equal, what does that equal? Negative 1/3 to looks like 3/3 or 1. And we know that this function is only defined for x values that are 0 and greater. So this interval can kind of go to 0 to 1, right? Because negative 1/3 doesn't exist on the interval anyways. So really we just want to know what the probability from 0 to 1 is. So we're going to take this down here. So the probability from 0 to 1 is just going to be the probability that x is less than or equal to 1. And lo and behold, we've actually already solved for this, right? So we solved for this in part C. And because we solved for it in part C, it is just, in part C, it is 0.95. Okay, guys, if you have any questions about exponential or Poisson or really any of the concepts or the problems, write about it in the discussion forum. I will answer the questions as soon as possible. I'll get the review up as soon as I can, but I wanted to get these lectures up as soon as possible, and I just was not able to get the review done now. So the review should be up in the next couple of days. All right, that's that. Thanks so much for your time, and yeah, till next time.